From the earliest civilizations, human beings have gazed at the night sky, pondering the stars, the moon, and the vastness of the cosmos. The ancient quest to understand the heavens laid the foundation for many of the scientific principles that shape our modern world. But long before telescopes and space exploration, early astronomers embarked on their own journeys to unlock the mysteries of the universe. In ancient Mesopotamia, the birthplace of civilization, people began charting the movements of celestial bodies around 3000 BCE. The Sumerians, Babylonians, and Assyrians observed the regularity of the stars and planets, noting their cycles and how these patterns influenced the seasons. They realized that the movement of celestial bodies was not random, but instead followed a predictable order, a concept that would become the cornerstone of ancient astronomy. One of the earliest known astronomical tools was the sundial, used by the Sumerians to measure the passage of time. But it was the Babylonians who took this observation of celestial cycles to the next level. They meticulously recorded the positions of planets like Venus, Mars, and Jupiter, and with these observations, they developed a complex system of astrology. They believed that the movement of these planets had a direct influence on events on Earth, from kings' fates to the rise and fall of empires. While astrology was often entwined with superstition, it also marked the first steps toward understanding the relationship between the cosmos and terrestrial life. In ancient Egypt, astronomy was closely linked with religion and governance. The Egyptians divided the day into 12 hours of daylight and 12 hours of night, creating the first known division of time that we still use today. Their observations of the stars helped them in practical matters, like predicting the annual flooding of the Nile River. The alignment of their grand temples and pyramids with the stars reflected their belief in the divine connection between the heavens and earth. The Great Pyramid of Giza, for example, is aligned with the star Sirius, the dog star, which was crucial to the Egyptian calendar and their agricultural cycles. But it was in ancient Greece where astronomy began to take on a more scientific approach. Greek philosophers like Pythagoras and Plato speculated that the Earth was a sphere and that the heavens were governed by mathematical laws. Yet it was the Greek mathematician and astronomer Hipparchus who is often credited with revolutionizing the study of astronomy in the 2nd century BCE. He compiled the first known star catalog, meticulously recording the positions of over 850 stars. Hipparchus also observed the precession of the equinoxes, the gradual shift in the Earth's axis over time, which meant that the stars visible in the night sky would change over centuries. This discovery was a critical step in understanding the long-term dynamics of the cosmos. However, it was the work of Claudius Ptolemy, an astronomer in Alexandria during the 2nd century CE, that would shape Western astronomy for over a millennium. Ptolemy's Almagest, a comprehensive treatise on the movements of the stars and planets, introduced the geocentric model of the universe, which held that the Earth was at the center and that all celestial bodies orbited around it. This model, though incorrect, would dominate Western thought until the 16th century. But in Ptolemy's time, his geocentric theory was revolutionary in its mathematical accuracy. The complex system of epicycles, small circular orbits within larger orbits, explained the apparent retrograde motion of planets, and this idea would persist as the best explanation of planetary motion for over 1400 years. The ancient Indian subcontinent also contributed greatly to the development of astronomy. The Vedic texts, written over 2,000 years ago, contain references to the movement of celestial bodies and their influence on life on Earth. Ancient Indian astronomers, such as Aryabhata, were far ahead of their time. Aryabhata's work in the 5th century CE proposed that the Earth rotates on its axis, an idea that was later confirmed in the Western world. He also developed an approximation for the value of pi and calculated the length of the solar year to within 0.5% of its actual value. Aryabhata's contributions would influence later Islamic astronomers and eventually the Renaissance scientists of Europe.
During the Islamic Golden Age, scholars in the Middle East built upon the knowledge of ancient civilizations, including the Greeks, Indians, and Persians. The work of astronomers such as al-Battani and Ibn al-Haytham advanced both the observational and theoretical foundations of astronomy. Al-Battani's work, for instance, provided more accurate measurements of the length of the year and the precession of the equinoxes. Meanwhile, Ibn al-Haytham, known as the father of optics, made crucial contributions to the understanding of light, vision, and the properties of the lens, which would later be fundamental to the development of telescopes. The ancient world's astronomical knowledge would be crucial during the European Renaissance. In the 16th century, a man named Nicolaus Copernicus would challenge the long-held geocentric model by proposing the heliocentric theory, that the sun, not the Earth, was at the center of the universe. Although controversial at the time, Copernicus's theory, combined with the observations of later astronomers like Johannes Kepler and Galileo Galilei, would eventually replace the Ptolemaic model and set the stage for modern astronomy. Kepler's laws of planetary motion, which described how planets move in elliptical orbits around the sun, combined with Galileo's telescope, which allowed him to observe the moons of Jupiter and the phases of Venus, solidified the heliocentric theory. Galileo's discoveries led him to assert that the heavens were not perfect as previously believed, but instead were full of dynamic, changing bodies. His work directly challenged the Church's teachings, leading to his eventual trial and condemnation, but it also laid the foundation for the scientific revolution. By the 18th century, astronomers like Sir Isaac Newton, building on the work of Kepler and Galileo, had developed the laws of motion and universal gravitation, which explained not only the motion of planets, but also the behavior of objects on Earth. With Newton's work, the understanding of the cosmos entered a new era, one that would lead to the eventual exploration of the stars, the discovery of new planets, and the understanding of the universe as we know it today. Ancient astronomy not only provided a way to measure time and understand the world around us, but it also sparked the human drive to explore, question, and innovate. From the first recorded observations of the night sky by the Babylonians, to the heliocentric theories of Copernicus and Galileo, to the cosmic discoveries of modern astronomy, the pursuit of knowledge about the stars has been a cornerstone of human progress. These early astronomers shaped the way we view the universe, and their legacies continue to inspire the quest for discovery. Through their ingenuity, they unlocked the door to the stars and beyond.